I want you to recall for a moment that in order to be simplified, the square root of an expression has to contain no perfect square factors under the radical, no fractions under the radical, and no radicals in the denominator of a fraction. We also talked about the quotient rule, which basically said as long as a and b are non-negative real numbers and b does not equal 0, we can pull apart or put together. In other words, if I have a fraction under the radical, I can give the numerator and denominator their own radicals. On the other hand, if the numerator and denominator have their own radicals, I can put them under one big radical. That's going to be useful to us when dealing with fractions. Now, for now, we don't know how to deal with number 3 at all. When we're stuck with a square root in the denominator of a fraction, we have a big problem that we can't deal with. So we're going to try to avoid that situation. So here's what we're going to do. If the denominator is a perfect square, then we want the numerator and denominator under separate radicals. In other words, we're going to break them apart and put them in their own radicals. We are going to simplify our radicals, and then we're going to simplify our fraction. This is for now. Later, we are going to learn how to deal with a radical in the denominator. If the denominator is not a perfect square, then we want the entire fraction under one radical. And instead of simplifying the radicals and then the fraction, we're going to simplify our fraction. And of course, we only have one radical, and then we're going to simplify that radical. So we're trying to avoid number 3. We don't want to be left with a radical in the denominator of a fraction. This will allow us to do that. Well, for now it will. Later you'll hit problems where you will wind up with that situation regardless. Okay, so we're going to simplify each of the following. We're going to assume all variables represent non-negative real numbers. Therefore, we can use our quotient and product rules. Is the denominator a perfect square? Yes, it is. Then we're going to separate them. Square root of 72 over the square root of 9. Let's take a look at the square root of 72. The square root of 72. Well, the largest perfect square is 36. It goes in 2 times. And so we get 6 times the square root of 2. So let's replace the square root of 72 with 6 times the square root of 2. And in the denominator, we've set it up so it is a perfect square. We have the square root of 9, which is 3. Now we need to simplify our fraction. 3 goes into 3 once, and 3 goes into 6 twice. Remember, never cancel someone out of jail with someone in jail. They don't get to consort. So what are we left with? 2 times the square root of 2 over 1. And we could just write 2 times the square root of 2. Next problem. Is the denominator a perfect square? Yes, it is. Break it apart. Can we simplify that numerator? Are there any perfect squares that divide evenly into 6? No. But the square root of 9 is 3. Notice 6 and 3 have a common factor. Can we cancel that common factor of 3? Absolutely not. 3 is not in jail. 6 is. We cannot cancel common factors. We are done. Is the denominator a perfect square? No. Therefore, we do not want to separate it. we want to simplify that fraction. Is 27 divisible by 3? Yes, it is. 27 thirds is really 9. And of course, the square root of 9 is just 3. Okay, look at the denominator here. Is the denominator a perfect square? Well, x squared is a perfect square, but 2 is not. Therefore, we say no. Let's see if we can cancel common factors. So we're going to keep that. We're going to simplify our fraction and then simplify our radical. So 8, well, 2 and 8 have a common factor of 2. I have to put the 4 above. Remember that it is under the radical. We can cancel these two x's if we get rid of 2 x's here. That leaves us with 3. So in the numerator, we have 4x cubed, and in the denominator, we have 1. So that's really the square root of 4x cubed. We need to simplify. So we simplified our fraction. Now we're going to simplify our radical. 4 is a perfect square. And the highest even number less than or equal to 3 is 2, so we can put 2 x's here, and the remaining factor of x goes there. We engineered this, so these are all perfect squares. We take the square root. Square root of 4 is 2. Square root of x squared is x. And we keep that square root of x. Is the denominator a perfect square? Well, 16 is a perfect square. A squared is a perfect square. And b to the 4th is a perfect square. So yes. So we're going to separate the numerator and denominator under their own radicals. Now what I'm going to do is I'm going to take the numerator off to the side, the square root of 20ab, and I'm going to simplify that. Perfect squares, whatever's left. Well, 4 goes into 20 5 times. We can't pull any even powers of a or b out. Both a and b go in the second radical. The square root of 4 is 2. And then we have the square root of 5ab. That's the numerator. So we have 2 times the square root of 5ab. And now the denominator, well, they're all perfect squares, so we should be able to take the square root. The square root of 16 is 4. The square root of a squared is just a. And the square root of b to the 4th, well, half the exponent is 2. Now that we've simplified our radicals, we want to simplify the fraction. This is a common factor of 2. What about the a's and b's? Well, this a is not under a radical. This one is. We cannot cancel. This b is under a radical. These are not. We cannot cancel. So we're left with 1 times the square root of 5ab over 2ab squared. And we are done. In this problem, we have 10 minus the square root of 75 in the numerator and then 5 in the denominator. I really need to simplify the square root of 75 before I continue. So perfect squares, whatever's left. Well, 25 goes into 75 3 times. And the square root of 25 is 5, so we get 5 times the square root of 3. So now let's rewrite that. We have 10 minus, and instead of the square root of 75, we're going to put 5 times the square root of 3. Our denominator is still 5. Now, we want to simplify our fraction. And we could factor out the GCF in the numerator, Or we could recognize every term has a factor of 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And 10 divided by 5 is 2. So we're left with 2 minus 1 times the square root of 3 over 1. And that's our final answer. Now, if you choose to factor out the GCF, you should still wind up in the same place. However, learning to simplify like this is actually going to be handy for you later when we deal with the quadratic formula.